Our planet Earth, a vibrant sphere teeming with life. Oceans ebb and flow, continents shift and collide. But have you ever stopped to wonder how this incredible place came to be? The story of Earth's formation is a cosmic puzzle stretching back billions of years. It's a tale of fiery beginnings, dramatic collisions, and the slow, steady march of time. We begin our journey not on Earth, but in the vast expanse of space. Imagine a time before planets, before stars, even before the very atoms that make up your body existed. This is where our story starts, with the Big Bang.
Imagine all of space and time compressed into a single point, smaller than an atom. This infinitely dense, hot speck was all there was. Then, in a cataclysmic event about 13.8 billion years ago, it happened. The Big Bang. The universe didn't explode into being, as the name might suggest. Instead, space itself expanded rapidly, carrying energy with it. Think of it like inflating a balloon. As you blow air in, the balloon's surface expands, and so do the dots drawn on it. That's the Big Bang, an expansion of space itself. As the universe expanded, it cooled. This cooling allowed energy to transform into matter, following Einstein's famous equation E equals mc squared. Tiny particles formed, followed by atoms of hydrogen and helium, the simplest elements in the universe. The universe was a chaotic sea of these elements, but within this chaos, order began to emerge. Gravity, the invisible force that draws matter together, started to sculpt the universe. Regions with slightly more matter attracted more matter, growing denser over eons. These dense regions would eventually become the birthplaces of stars and galaxies, the building blocks of our universe. About 4.6 billion years ago, in a nondescript corner of the Milky Way galaxy, a cloud of gas and dust began to collapse under its own gravity. This swirling cloud, called a solar nebula, contracted further, spinning faster and faster. The temperature at its center soared. Finally, the pressure and heat at the core became so intense that nuclear fusion ignited. Hydrogen atoms fused to form helium, releasing tremendous energy. Our sun, a blazing ball of plasma, was born. From dust to planets, the solar system's formation. The story of our solar system's birth is a tale of cosmic dust and gas, swirling and colliding in a vast dark expanse. It all began in a giant molecular cloud where tiny particles started to stick together, forming larger and larger clumps. The sun's birth wasn't a solitary event. It was part of a grander process, a cosmic dance that involved countless other stars being born in the same stellar nursery. This stellar nursery was a chaotic place, filled with the raw materials needed to create stars and planets. The solar nebula, still swirling around the newborn star, played a crucial role in shaping our solar system. This rotating disk of gas and dust was the birthplace of everything we see in our solar system today. The forces of gravity and angular momentum worked together to flatten the nebula into a disk. Dust and gas within the nebula continued to collide and clump together. These collisions were not random. They were guided by the gravitational pull of the forming sun. Over time, these clumps grew larger and more complex. Over millions of years, these clumps grew larger, forming planetesimals, the building blocks of planets. These planetesimals collided and merged, creating even larger bodies. This process of accretion was slow but relentless, gradually building up the planets we know today. The inner solar system, closer to the sun, was hot. In this region, only materials with high melting points like metals and silicates could condense. This led to the formation of rocky planets. Rocky materials like iron and silicates condensed, forming the terrestrial planets, Mercury, Venus, Earth, and Mars. These planets are characterized by their solid surfaces and metallic cores. Further out, icy materials could also condense, leading to the gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets formed in the colder regions of the solar system, where ices could remain solid. They accumulated vast amounts of gas, becoming the giant planets we see today.
Earth's fiery youth, a molten cradle. In the beginning, our planet was a seething, boiling mass of molten rock and metal, a far cry from the blue and green world we inhabit today. In its infancy, Earth was a hostile world. The surface was a chaotic landscape of fiery lava flows and erupting volcanoes, with temperatures soaring to unimaginable heights. The constant bombardment of planetesimals, remnants from the solar system's formation, generated immense heat, melting the planet's surface. These collisions were so intense that they liquefied the outer layers of the Earth, creating a vast ocean of magma. This molten Earth was a sea of magma, a fiery ocean of liquid rock. The surface was in a state of perpetual turmoil, with molten rock churning and flowing like a hellish sea. The heavier elements like iron and nickel sank towards the center, forming Earth's core. This process, known as differentiation, was crucial in shaping the internal structure of our planet. Lighter elements, like silicon and oxygen, rose to the surface, forming the planet's mantle and crust. These elements combined to create the solid outer layers that would eventually cool and harden into the Earth's crust. Volcanoes erupted violently, spewing gases and molten rock into the early atmosphere. These eruptions released vast amounts of water vapor, carbon dioxide, and other gases, which began to form the early atmosphere. This period of intense heat and volcanic activity shaped Earth's early geology, laying the foundation for the continents and oceans we know today. Over millions of years, the surface cooled, and the first solid landmasses began to emerge, setting the stage for the development of life. Section 7. A Lunar Companion. The Moon's Formation. Early in Earth's history, a catastrophic event occurred, one that would forever change our planet. A Mars-sized object, often called Theia, collided with the young Earth in a titanic impact. The energy released was unimaginable, momentarily melting a significant portion of both bodies. Debris from this colossal collision was ejected into space, forming a ring of molten rock and dust around the Earth. Over time, this debris coalesced under its own gravity, eventually forming our moon.
Section 8. Cooling and Crust. Earth's Transformation. As the bombardment of planetesimals subsided, Earth began to cool. The molten surface solidified, forming a thin, unstable crust. Volcanic activity was still rampant, but the planet was slowly becoming more hospitable. Water vapor, released from the planet's interior during volcanic eruptions, began to accumulate in the atmosphere. As Earth continued to cool, the water vapor condensed, forming clouds and eventually raining down on the surface. This marked the beginning of Earth's oceans, vast bodies of water that would play a vital role in the development of life. Section 9. Air and Water. The Breath of Life. The early atmosphere was very different from the one we breathe today. It was a toxic mix of gases including carbon dioxide, nitrogen, and water vapor. However, this early atmosphere played a crucial role in the development of life. Over billions of years, primitive life forms emerged in Earth's oceans. These early organisms, through photosynthesis, began to release oxygen into the atmosphere. This oxygen eventually accumulated, transforming the atmosphere into the life-sustaining mix we know today.
Section 10. Unlocking the Past, Shaping the Future. Understanding Earth's formation isn't just about satisfying our scientific curiosity. It's about understanding our place in the cosmos. The story of our planet's birth and evolution is a tale that spans billions of years, involving cataclysmic events, gradual changes, and the intricate dance of elements and forces. By delving into this ancient narrative, we not only uncover the secrets of our own world, but also gain a deeper appreciation for the delicate balance that sustains life. By studying the processes that shaped our planet, we gain insights into the conditions necessary for life to arise. These processes include volcanic activity, plate tectonics, and the gradual cooling of the Earth's surface. Each of these elements played a crucial role in creating an environment where life could flourish. Understanding these processes helps us to predict future geological events and to mitigate their potential impacts on human civilization. This knowledge is crucial as we search for life beyond Earth, as we grapple with the challenges of climate change, and as we strive to ensure a sustainable future for our planet. The lessons we learn from Earth's history can guide us in our quest to find habitable worlds in distant star systems. Moreover, by recognizing the signs of past climate shifts and mass extinctions, we can better prepare for and possibly prevent similar events in the future. The story of Earth's formation is a reminder that we are all connected, not just to each other, but to the vast universe that surrounds us. Every atom in our bodies was forged in the heart of a star, and the same forces that shaped our planet are at work throughout the cosmos. This profound connection underscores the importance of preserving our planet and exploring the universe with a sense of wonder and responsibility. By unlocking the past, we truly shape the future, ensuring that the legacy of our planet continues for generations to come.